really easy for teams to make production-ready Python services. And I think we've been pretty successful so far. Over 20 teams use this framework, and I think this honestly probably lower estimate at this point. Over 30 services have been created to support generative AI experiences. And finally, if we kind of zoom out at an entire architecture level, at a system level, we invested into new distributed architecture to specifically support agentic modes of communication. So let's start from the ground up, and I'll talk about why we chose Python. So at 10,000 foot view, these are the languages that we use here at LinkedIn. Up until, I would say, late 2022, Python was really, and I like to call it Python here. Python we use mostly just for internal tooling, internal productivity tools, but also big data applications here. PySpark, offline jobs. But really, Java was used to build a vast, overwhelming majority of our business logic. And so, come LinkedIn 2022, which was really LinkedIn's first foray to generative AI, we saw that, hey, we're already using Java for non-generative AI use cases. Let's just use Java for Gen AI also. And some of you might be wincing. I can already anticipate that. So at that time, we built some really basic apps. They were just simple prompts with basic prompt engineering, little to no RAG, no conversational memory to speak of. And this was okay, and probably you probably predicted this part, but it was okay until it really wasn't. What we saw was a lot of teams, they wanted to experiment with Python. They wanted to use Python for prompt engineering for the evaluations, but because of our stack, they were forced to build Java and use that to build their services. So not only was that a problem, the more fundamental problem that we faced was how do you experiment with the open source libraries, the open source community, if your stack is fundamentally not Python? And as soon as there is that kind of language gap, then it was really difficult for teams, honestly, to innovate and iterate with the various techniques. It seemed like every month, every week, there'd be a new model being released, a new library, a new prompt engineering technique, a new protocol. And I'm sure all of you are acutely aware of this problem, that it's just, frankly, pretty hard to keep track of all the developments that's happening in the industry. It seems like there's something new being developed all the time. So we took a step back and we made a couple of key observations. First, there's undeniable interest across the company from teams all across different verticals that they want to use generative AI. We noticed that this generative AI, or for generative AI specifically, this Java Python setup really wasn't working out. And finally, we realized we had to use Python no matter what, because at the end of the day, we have to be on top of the latest industry trends and make sure that we can, make sure we're bringing those benefits into our stack internally. And so, hey, let's make a bold bet. Let's use Python for the business logic, the engineering, the evals, approach everything else that you would need to build a functional production application. And I'll say we even took the next step further, which is let's build a framework and make it the default. And specifically make a framework so that teams don't have to guess about what's the right way to do things. Instead, they can use this framework and take out some of the guesswork from it. So let me talk about exactly that. What was the service framework that we ended up building? At a high level, we use Python gRPC, and we use LangChain and LangGraph to model the core business logic. This isn't a talk about gRPC, so I won't go too much into detail why we chose gRPC. But at a high level, I listed just some of the features here that we really appreciated. Namely, its built-in streaming support was really awesome. Binary serialization is a big performance boost, as well as just the native cross-language features, which, if you recall the couple slides earlier, use a ton of languages. So having cross-language support was critical. So here I built a sample React agent using our application framework. So as we see here, there's standard utilities for tool calling, highlighted in kind of the yellow there. Standard utilities for large language model inference using our internal inference stack. Standard utilities for conversational memory checkpointing. And the key thing that I'd like to note here is that we use LangChain and LangGraph to tie all of this stuff together. And really, LangChain and LangGraph form the core of each of our generative apps. So then, this leads to the question of the hour is, why did we end up choosing LangGraph over the sea of other kind of different alternatives to build our and model our applications. The first thing I'd like to say is that it just plainly was really easy to use, and I'm sure everyone in this room can agree here that even what we saw was that Java engineers were able to pick it up really easily. Like if you look at the syntax, you can pretty easily identify what's happening, the kind of most basic construct here. And furthermore, through various community integrations, just like the community Vice implementation or the React agent pre-built from the LangGraph official repo, we're able to build non-trivial apps in days, down to weeks, which is, if you think about the number of teams that work on generative AI across the company, this is weeks, months of time being saved across the work. And the second thing that we really appreciated, and I think we've heard similar things from different speakers today, and that is the LangChain package and LangGraph package have really sensible interfaces. And so we're able to model our internal infrastructure using these interfaces. For example, if we look at this chat model interface here, LinkedIn uses Azure OpenAI, but also uses on-premise large language models as well. So teams, if they want to switch between model providers, they can do so with a couple lines of code, and that's that. So if we zoom out, call this diagram here. Essentially what I've described allows us to build one of these boxes, but then you might ask, how do we actually tie all these agents together? And so the two problems that we identified, specifically with agentic setups, was that, one, agents can take a lot of time to process data. This leads into the whole ambient agent idea where how can we model long-running asynchronous flows within our infrastructural stack? And second is agents can execute in parallel. And furthermore, the outputs of one agent might depend on the outputs of another agent. So how can we make sure that things are done in the right order? This leads me to the penultimate section of my talk, which is the new infrastructure that we built, and I'll call it our agent platform. So the first part of our solution was to model long-running asynchronous flows. We model this as precisely a messaging problem. And the reason why we chose messaging is because LinkedIn already has a really robust messaging service that serves countless members every day. And so we extended this to also include agentic forms of communication, namely agent-to-agent messaging, but also user-to-agent messaging as well. We even built some nice things so that if there's like a nearline flow where the messages get failed, they'll be automatically picked up and retried via the queuing system. So then that covers how agents can talk to each other. They can send messages to one another, but this doesn't cover how agents can actually make sure that tasks are done in the right order. So the second part of this solution that we developed was to specifically build memory catered for agents. And so our agentic memory, you'll probably see, I think you've seen things of this from people outside the booths as well, is that there's kind of different forms of memory that agents should be able to access. For us, it's memory is both scoped and layered. So there's working memory, long-term memory, collective memory, and these each provide different functions that the agent can utilize to do the things it needs to do. So for example, for a new interaction, you'll probably just fill out working memory. But over time, as the agent has more interactions with a particular user or something like that, then more memory will be populated long-term over time. So now we've covered the arrows and the boxes. So how do agents actually do things? Well, this kind of leads to what I was talking about before, where we've developed this notion of skills, which is like function calling in a lot of senses, but it deviates from this notion in a couple of different ways. The first thing is that function calling is usually local to your box, but here skills can really be anything. RPC calls, database queries, prompts, and more importantly, other agents. And the second thing that I'd like to emphasize here is the how. Specifically, we let agents invoke skills synchronously, but also asynchronously, which we consider the different themes that we talked about. The asynchronicity part is absolutely critical. And I'd like to think that we did a good job with the design here because overall, this setup is pretty similar to MCP well before it's actually around. So, and finally, we took this skill concept and made it centralized. And so we implemented a registry so team services could expose skills and register them in a central place so that then if an agent wants to access skills developed by another team, they can do so and discover these skills via this central registry. Let me walk you all through what a sample flow might look like. So in this case, the supervisor agent types the sourcing agent that I need help searching for the double engineer. The sourcing agent will contact the skill registry. The skill registry will respond with the skill that it thinks is a good fit for the task. And then finally, the sourcing agent will execute this skill. And like I said before, this links to the core components that we've built too. So again, the emphasis means make it really easy for agents to develop. And lastly, I could spend an entire hour on this topic, but we also build custom observability because agentic ways of execution require particular observability solutions. To wrap up here, I'd like to cover two things. First is, I think a key emphasis that we've discovered these past couple of years is to really invest in productivity. This space is moving incredibly fast, and if you want to make sure that you're kind of following best practices, but also available to adapt to different conditions or changes in the product, you need to make sure that it's really easy for developers to build. And so you can do this by standardizing patterns, making sure it's as easy for any developer to contribute as possible. The second thing I'd like to emphasize is, at the end of the day, we're still building production software. You should still consider the usual things, availability, reliability, but also, again, observability is paramount. You can't fix what you can't observe. And really, to do this, you need robust evaluations, things that people have talked about already. You should count on entrepreneurs to work with them. So that's all, and thank you.